So I did give a talk last month. I was not very satisfied with my performance. I think what people need is a learning path. Here I say, machine learning in Python from zero to hero. I think you don't need scattered facts about Python here and there. You need some track or path to go on so that you can begin from nothing and start learning about machine learning. Now, Python is a computer language, and learning Python is very much like learning a regular language. One of the first things you need to do when you learn a new language is to learn how to use a dictionary. You need to know some basic facts about the language. So I'm going to backtrack a little bit and go back over learning with Python. So my philosophy for this talk is right here, machine learning in Python from zero to hero. I shared this document with a prof, and he can share with everyone. But all of these materials is also at this URL. And I shared the URL in the chat right here. So if you want to follow along with me, you can go to this link as well. Go to your chat and you can click on this link and I can explain some of the contents. So this is a project that I started with some other colleagues in different African countries, where we are trying to assemble materials for machine learning that can be useful for people who are just starting out or doing research in the area. So today I'm going to go to this folder called links. And of course, you can keep this URL, and I hope that these links will continue to be useful for you. So I'm going to start out with this one, links to Python courses and tutorials. All right. So in order to use Python, you do need to have a Python platform. Now, last time I talked about installing Anaconda, but in fact, there's an easier alternative than that. You can use Python without installing anything on your machine. So I can, if I can move this, I don't want this bar here. I don't want to get rid of it. Okay, there we go. If you just Google Colab, I just Google this website, you'll find Welcome to Collaboratory right here. If you click on this, you will find a fully functional Python on your computer through the web. This Python is not running on your machine, it's running in the cloud. So there's no installation necessary. This is a notebook where you can program. I'm going to mute the chat so I have some room here. But you can program in this notebook. You can run Python programs. You can copy Python code into this notebook and make it work. All right. So I'll be demonstrating that shortly. Now, as I mentioned, I do want to introduce a learning path. And fortunately, there is one learning path that really, I'm sorry, I don't want that site. That site, I don't want this. Okay, there's one learning path which really is self-contained, is this W3 Schools website. There are alternative websites, but this one can really take you from the beginning through more advanced machine learning. So if I click on this site, and you can also click on this link if you've gone to the links page that I showed you, you can click here. And what you will find, if you scroll up here, you will find a complete Python tutorial. So, and this Python tutorial is complete with code and with exercises. Let me start, for instance, and this one, Python variables. If I click on this, they will tell you some things about variables. Okay. Here they have some code, and it says, try it yourself. So you can click on this, and you can actually run Python code here. I think I talked about this last time as well. If I run this, then it will give me my output. Now, when you're going through these tutorials, you really should try to modify them and see if you understand what's going on. So suppose I want to change the number here, and this 666, and I'll say this is the number of the beast, okay, and see if I can understand what is going here. So, and it runs 666 is the number of the beast, okay? Now, the other thing you can do is copy this code. I can copy this code. So I right-click and then copy. And then I'll take it to my Google Colab page, which is still open here. And I can paste it here. I should paste, let's see. Okay. And I can run the code here just by pushing this button. It will take some time to load. It's connecting. And then it will print out my result. Should print out. I'm still connecting. All right, but sometimes it's a little bit slow. Once you're connected, it will be much more rapid. So there we go, it's connected. It should just take a moment. Okay, so it printed the output here. Now, this code here, when you close this web page, this code will disappear unless you save it to your Google Drive. So I can go File, and I can save a copy in Drive. So if you have a Google account, you can save your code in Drive and then open it again. And here I can change the name. I can call this instead, I'll copy it, call it a code from W3 schools. So if you have, as I said, if you have a Google Drive account, you can create these web pages, which are essentially Jupyter notebooks. This IPYNB means it's a Jupyter notebook, which is a one interface with Python. And this will be stored on your computer. Okay. So if you go through this Python tutorial, you have various things you can try, different examples. So I recommend you go through this, think about each example, make sure you understand what's going on with each example. Go down like this, and at the end there should be some exercises. Oh, I'm sorry, the exercises are here. Exercises are very important. You cannot, I like to say you can't learn to ride a bicycle by watching. You can watch someone ride a bicycle and say, oh, yes, I understand. They get on the bicycle, they move their feet, the bicycle goes forward, and they steer with their hands. I understand perfectly. But no, you don't understand anything. Because if you yourself cannot get on a bicycle and ride it yourself, you do not understand anything about riding a bicycle. So please, when you go through and learn Python, do the exercises, right? The very nice thing about this W3 Schools is that it will check your answers for you. So for instance, this exercise says, create a variable named car name and assign the value Volvo to it. Okay, so I'm going to say Volvo equals car name. Okay, whoops, car name. Well, it doesn't fit, but we'll just, so I'll submit my answer. And here I'll submit my answer here, and it says not correct. Okay, so let me try again. Now, see, the thing is that the variable is named car name, and the value is Volvo. If you know anything about assignment statements, the variable name goes on the left, and the value goes on the right. Okay, so it really should be this way, Volvo. Okay, and you submit your answer, and it's correct. Okay, So you can see how this works. There's several exercises here, and this goes through all the basics you need for Python. Okay, even more so. All right. So if you go here, you can see what I list as what's necessary to get for a basic knowledge of Python. So this is really necessary for you to understand these things if you want to understand Python code. Okay. So you can get familiar with these concepts just by going through W3 schools. Now, the next step is going beyond these basic features and learning about Python packages. Two important packages are NumPy and Matplotlib. NumPy is for numerical mathematics. Matplotlib is for plotting. Fortunately, W3 Schools has tutorials for these as well. Let me see if I can get there. Looks like here go back to my W3 Schools main page. And here, if I scroll down, NumPy tutorial, Pandas, SciPy, and Django. I don't even know what Django is, but NumPy is useful for numerical Python. Pandas is useful for data handling. Pandas is very much like R. And SciPy for advanced scientific Python. Then they have a tutorial on Matplotlib. Okay, so you can have different aspects here. So, and this all has the same structure. You can see you have the code. Here I'm importing the module, and here it shows me how to create a line. And here's the result. And then they say, try it yourself. And as I mentioned, if I want to do this in my own computer and save it for myself, I can copy this code and run it in my own Colab window. Now, one thing about this case is this is a comment that says 3 lines to make our compiler able to draw. I do not need these 3 lines because I'm running in Colab. Here they need these 3 lines in order to run in this window. I also don't need the last 2 lines. So I can simply copy this part here. I can copy that. I press Control-C to copy it. And here I can create another code cell. I can paste it here with Control-V, and then I can run this code here. Okay, it takes a little time to import these modules. Once they're imported, then they will stay in your session. Okay, and we can scroll down and see the result. Okay, now you can do this very simply yourself. And also I can do I can add some points here and do something different. This is fully functional code. Whoops, let's see, 6, 10, 22, 29, and then I can do 250, 49, 78. Okay, and then let's run it now. Okay, error. Now, one very important part about Python is understanding the error messages. You can't just say, oh, it doesn't work, I give up. No, Python is very explicit about what is wrong. Learn to read the error messages. We go down and we see here it says very explicitly, X and Y must have the same first dimension, but have shapes 5 and 4. What does that mean? It's referring to X and Y. Now, X and Y are the X coordinates and Y coordinates of my plot. Now, how did I specify the X coordinates and Y coordinates? Well, X points were the X coordinates and Y points were the Y coordinates. Now, it's telling me down here that they have shapes 5 and 4. So there's something wrong with the way I specified my X coordinates and Y coordinates. Now look here. I specified 1, 2, 3, 4, 5 X values and only 4 Y values. So the problem is I need another Y value to match with the X value. So I just do that and run again. Okay. Learn to understand the error message. Very important. Very, very important. Now, error messages get more complicated as you go on, but the Python developers have put a great deal of effort into making error messages that inform you what's wrong with your code. Okay? So that's the next step. Learn about these modules. Okay? So if I go back to my outline, now we want to talk about machine learning. All right? In fact, W3 Schools has some tutorials on machine learning. We can go down and see. So really, I'm very lazy with this talk. I'm letting W3 do everything for me. So here, I guess I was here. So matplotlib, machine learning, machine learning. So this is very simple machine learning, not deep learning, but these are important if you want to do some basic data analysis. And often these classical methods are better or at least as good as the fancy methods. Please don't jump to the fancy methods first. Understand the basic methods, understand the statistical basis, and then you can go on and do the more fancy methods. There's so much, may I say, garbage out there in the research literature because people don't understand the basics and they try to jump to very complicated things without understanding anything at all. All right, so suppose I'm interested in some topic. Maybe you've heard about k-means. K-means is a method for clustering. Okay, so here's a tutorial on k-means. So let's look and see what they say about k-means. Now, you may not understand what k-means is, but there are other references you can find about k-means. Right. So here they explain that k-means that you specify the number of clusters, and then k-means will group your data into different clusters. Okay. So suppose you have a problem where you want to cluster data. You can in fact grab this code and modify it. Unfortunately, I don't have any code that I can use, but here let's take this example. So here they say they give me some code and they plot it. And here they have run example. The best way to copy the code is simply do this. Now remember, these here I only want these sections here. And I can copy this into my own Jupyter code window. I'll set a new code cell and put it here. So I'm learning about k-means. So let me plot this data. And here it looks like this. Okay. Now I'll go through this example and maybe I can change my data later. Okay. So I'm going to comment this, and this is good. It's going to be a plot. It's always a good idea to visualize your data. Now, this is two-dimensional data, but you can actually do multi-dimensional data. It's not a problem. Let me go back to my W3 schools again. All right, so I don't need this window anymore. I don't need this window. Let's see, where am I? I don't need this window. Let's see. I don't need this window. Too many windows open. I don't need, all right, so here's where I am. Okay, so I'm back here. All right, so let's go on and see how we apply clustering in this case. All right. So here's a lot of code. You can try to understand line by line what this is doing. All right. Here it says from sklearn cluster import k-means. This is a library and this is a function. This is going to accomplish the k-means that I want to do. Data equals list zip of xy. Apparently, this is putting xy together into a single data set instead of two separate lists. Okay, so then we go from I equals range 1 to 11. Okay, so I is a variable that will vary. Now here it looks like we're clustering with different clusters. We're applying this function k-means to get a result. So k-means is now the method. I use this method to fit the data. and then I append inertias. Apparently, this is a measure of how well the k-means is fitting. So let's see what this does. Well, here they show me the result here, but then they say try it yourself. I can copy this code again. I'll copy this and I'll paste into my Colab window. Okay, this is my Colab window, right? Okay, so I've got this. Okay, so here I'm going to do, what I want to do is let me insert a text cell here, and I say on the following cells, implement k-means on data. Okay. And then we'll run this cell. Okay. So here we go. We have, this is the first one. Now I want to do my second cell, which I'll paste below. I'll click here and add another code cell, and I will add it here. And let's see what this does. It shouldn't take that long. I guess it has to import k-means. Every time you import something, it takes more time. Let's see. And here we have the elbow method. So I can't go explain this in detail. What this is saying is that 2 clusters basically gives me all of the, is the best choice for me, because after here, you're just getting marginal improvement. And you can also explore what's going on here. For instance, here it says data equals list of zip XY. What is data actually mean? Well, I can add a code cell down here and I can print data. And data looks like what? So what it's done is it put the X and the Y together. Okay. Right. So let's see. So let's continue with the tutorial and see if they do more for me. All right. So here they explain step by step what they're doing. Okay. All right. So you can go through this in detail. All right. So here now they show what the clusters are. It's a very nice way to represent what the clusters are doing. So I can grab this code and do the same thing. I'll put this in my code window, and you can see that I will get the same result. I don't need this cell anymore, so I'm going to overwrite this cell. I'll just remove that and do this. And we can see that we get the plot out. Right? We get those 2 clusters. Right. Now, suppose I want to do a more complicated example with some other data. So let's try to do, and I haven't prepared this, but we might as well try this, see how it works. So I'm going to insert another code cell. So I'm going to do k-means with multi-dimensional data. All right. So what I'm going to do is let me generate 2. I'm going to generate a 2. Let's call them 5-dimensional, normal clusters. Okay. Now, so in order to generate random numbers in Python, I have to look up how to do that. So here I want to say Python generate normal. I can say a normal sample. All right. Let's see what happens here. Here we go. numpy.random.normal. Okay. And here's one, how to generate a normal distribution. Now, this statology may actually give me some good code. So let me look here. You learn to find the sites that will give you good information. The way to program in Python is Google and copy, Google and copy, Google and copy. All right. Now, this is a very clear specification of this function. This is the name of the function. This is the mean. This is the standard deviation, and this is the size. Okay. So I'm going to copy this. Let me copy it. and I'll go right here. And here we go. So I'm going to, so this will be my the first cluster. And let's see, let's say it has let's say it has mean 0. And then it will have, and let's see, it has mean 0 and it has, let's say, a variance, or standard deviation 2, right? So let's say mean equals 0 and standard deviation is equal to 2. Okay. Then what I want to do is generate my random normal variable. Well, log is equal to mean, a scale is equal to standard deviation, and I want 5-dimensional normal clusters. So let me say so the number of points, let's say number of points equals 100. Okay. So, and then I'll say dimension is equal to 5. So here I want the size to be equal to 105. Right? So let's see if that works. Okay. Oh, I need to set this equal to something. So I'll call this sample 1. And let's run it. Okay, something is wrong. Let's see what I did wrong. Whoops, where are we? Let's go down and see what I did wrong. All right, name numpy is not defined. All right, why is it not defined? Because I didn't define it. Numpy is a library, so I have to import numpy. Now, typically, when you import numpy, usually when you look at code, they'll say import numpy as NP. And if I do it this way, then instead of typing numpy here, I can just type the prefix NP. So let's try it again, see if I have any errors here. All right, looks fine. Now, it doesn't show me anything because I didn't ask for any output. So let me print some, sorry, I didn't mean to do that. Let me add some code and let me I want to show some samples. So I'm going to print, let's see, what do I want to print? I want to print sample 1, and I don't want to print all 100 samples. Let me just print sample 1 from up to, let's see, up to the first 5 samples. And let's see if I use the right syntax there. Okay, so these are the first 5 samples of my 5-dimensional random sample. All right, now let me make a second sample also. So I'll add some code here. So create a second sample. Okay. All right, and then so let me copy this code up here. Or I should say I'll create a second cluster. Okay. I'll call this a second cluster. And here I want then my second cluster will be second cluster. Let's make it say, let's say it has mean 2 and standard deviation 1. Okay. Now you see the beauty of programming. I already know how to generate and here I'll just have 50 points. Okay. I had 100 points in the first one. Here I have 50 points. Okay, so this is, I'm going to do this with multidimensional data. Okay, so here my mean is 2. My standard deviation is 1. My number of points is 50. Whoops, standard deviation is 1. Number of points is 50. Still, I want 5-dimensional data. Okay. And sorry, I should see, the thing is, I shouldn't have put 100 here. I should have put num points and dim. So I broke one of the main rules of programming, which is you should always define your variables at the beginning and then only use variables. So let me go up and fix my code up above because I might want to use it again. This shouldn't be size 105. It should be size num points and dim. All right, so if I run this again, it will give me the same result. It really doesn't matter, but I'll go ahead and run it again, make sure I didn't make any mistake. All right, so it's fine. I can show my samples again and see if they still look reasonable. Now, of course, I'm not going to be able to plot 5-dimensional data. That's not really possible. But I can generate 5-dimensional data. My point is to see if it will identify two clusters or not. Okay. So you're going to create a second cluster, and I don't want to call this sample 1. This should be called sample 2 because it's a different cluster. Okay, mean 1, standard 1. I think this is, mean 2. Sorry, it should be mean 2. Okay, mean 2, standard deviation 1, 50 points. Okay, so let's go ahead and generate this cluster here. Okay, and then I can also copy this up here, and I'll just show some samples. Oops, it's not copying. There we go. So I'm going to, so we'll look at sample 2. And I'll click here. I'll add some code. I'll copy it here, paste, sample 2. I'll just show the first 5 of these. Now remember, this sample has mean 1, mean 2, and standard deviation 1. So that means that the value should cluster around 2. And here we see 1, 2, 1, 2, 1.9, 2.6. Okay, so it's looking quite reasonable. Now I want to put all the data together. So I'm going to put the 2 samples together as a single data set. Okay. Now what I really have, I have 2 lists, and I want to concatenate those 2 lists. So I can look up here, concatenate lists. Well, actually, I don't know if they're lists or arrays. So so find a data type in Python. Okay. And let's see, it says built-in type. Okay, so I don't know if they're lists or arrays. Let me see. So let me find out first type of sample 1. And we'll see what it is. It is an array. Okay, so I want to concatenate these 2 arrays. I can't go into detail about the difference between list and array, but array is especially for NumPy. So I want to concatenate. Concatenate means put one after the other arrays in NumPy. All right, so let's see, numpy.concatenate. Okay, very good. All right, now here, even in W3 schools, it shows me how to do this. So I like to go here, and it will certainly give me some example. All right, here they have 2 arrays, and here they just say NP concatenate array 1, array 2. Okay. All right, now the problem is I don't know whether to join them. There are 2 ways to join 2-dimensional arrays. You can either put them side by side or one on top of the other. So let's see what we want to do here. Well, it looks like we want to. So we certainly want to put. We want to put them together. So I say. So let's say data set is equal to np.concatenate. And then let's see. I have to check the syntax and make sure how to do this. All right, so you need to put in parentheses, you need to put what you want to concatenate inside another set of parentheses. Okay, so 2 sets of parentheses there. All right, so here I'm going to do sample 1 and sample 2. Okay. All right, now we can just try this and see what it works. And I want to find out what the shape of the result is. Okay. And I'll print. Oops, sorry. Now, one thing that's very nice about Colab is that it will also tell you, whoops, why is it going there? It will also tell you what different, it will also tell you what different functions do. So let's see what this does. Okay, 150 and 5. This is correct. Why is it correct? Because my first sample had 150 5-dimensional samples. My second sample had 50 5-dimensional samples. So now I have a data set with 150 5-dimensional samples. Okay, so let's go ahead and try to apply my clustering to that. Remember, I have my clustering code at the very top. And this is what I copied from the W3 schools. right? So let's, now I've already imported these, but let me just go ahead and import again, just so that I can run the, that part of the code by itself. So I'll put this into my code, into my window. It's not going to hurt to import it again. And then let's see what other code I need to do the k-means. Let me go back up and see what they did in k-means here. Okay. All right, so it looks like we have, I don't think we need this part. Now, this was just to show some things. Well, no, actually, we can just do the same thing. Now, I already have my data, so I don't need to do this. Let me just start from here. I'm going to be using my new data set. So let's see if this works. I don't know if that's going to work or not. We may have to do some adjusting, but you just go step by step and see what you can do. Okay. All right, so we do this. This is going to fit 11 different clusters. Now here it's fitting data, but I don't think I called my data as data. I think I called it data set. Let me see what I called it here. I called it data set. Okay, so my data is not called data, it's called data set. Okay. All right, now let's see. So let me see if I've defined everything I need. I have my k-means here, my inertias I'll create. Here I'm going to look at 11 different numbers of clusters. I'll apply k-means on my data set, and then I'll append the inertias, and then I'll plot the inertia. Well, let's see if this works. So I expect that since I created 2 normal clusters, I expect an elbow around 2. And hopefully there's no errors. We'll see if there is. All right, no errors. Let's see what the picture shows. All right. Well, here it's not so clear. The elbow is not quite so clear. I think it's because the 2 clusters are very close together. Now, if I did something else and changed the clusters, I could make the separation more explicit. Let's go back here and change my second cluster. Okay. Instead of having a mean of 2, let me make this have a mean of 5. Then that will be a very clear second cluster. All right, so I'll run this again. And then I will, whoops, sorry. It's here, can I roll this up? Okay, yes, I can roll this up. I should be able to get rid of that. Okay. Okay, what's my next one? So I executed that again. I don't need to execute that. Well, let me show my samples again. Now they should be centered around 5. Yes, they're much larger now. And I'll put the 2 data sets together. And then we'll apply this clustering. Okay. And let's see what it looks like now. It should be a lot more explicit. Yes, you can see it's a lot more explicit now. Okay, so that's just one possible way of learning something. Now, suppose you want to learn something about a topic that's not in W3 schools. W3 schools has a limited number of topics. Okay, for instance, suppose you want to learn about deep learning, which of course is a very popular topic. If I go back to my outline here, you can search for machine learning notebooks online. Okay. Now here I said one example search would be natural language processing IPYNB. Okay. Now when you say IPYNB, that shows shows Google that you're looking for a Jupyter notebook. Okay. Why don't I try this? I can look for natural language processing IPYNB. And then you want to go down. Some of these are advertisements, so you can pass by the advertisement. Usually always the first, when it says sponsored, you can pass by that because they're trying to get money. Okay, so just go past the sponsored. All right, now here we go. Natural language, you can see I visited here before. Natural language processing with RNNs. Okay, so I looked at this one before. Let's look at this one here. A Python Introduction to Natural Language Processing. Okay, let's look at this. It says Python Data Camp Introduction to Natural Language Processing. Now, this is in GitHub. GitHub is a repository that has a great deal of material that you can download. And you can see that this notebook is part of a larger repository that's here. Okay, so I'm going to click there, and here's my repository data camp. And this, let's look what's in here. This has a lot of notebooks here, not just about natural language processing, many, many notebooks here. So what I can do is download all of these. Okay. So to download, I go to code. So you should become familiar with GitHub because it's the primary repository for files, and you'll find lots of Jupyter notebooks here. You can download the zip file, and you show in your folder. Why is it not showing in my folder? Let's try again. Okay, there. It's here. I can unzip it. And I can extract it here. That's fine. Let me move this bar. And then I can go into the folder. Where's the folder? The folder's here. And here. And you'll find many, many different notebooks here. Now, I can open these notebooks in Google Colab. There may be some problem because they're images as well. But you can open these notebooks in Google Colab, or if you have Jupyter installed on your machine, you can open these in Jupyter. So let me show you. So first I'll show you how to open in Colab, then I'll show you how to open in Jupyter. Okay. So let's see, my Colab window is here. Okay, and this is now in my Google Drive. Let me go to another. Now I go to another file. I can say open. I can say upload notebook, or I could simply put the notebook in my Google Drive. But I can upload notebook, and I can go to upload. And I really don't like this bar, and I choose my file, and I go to the folder that I just downloaded in my downloads folder. And it was here. And let's see which one I want to open. And let's see, do they have deep learning? Well, TensorFlow is one of those. I happen to know this one doesn't work too well. Let's try feature engineering for NLP and Python. Let's see how this works. So this notebook is now in my Google Drive, and I can run this notebook, okay, just like I ran the other one. You may have to download install some other packages. That's possible. But here you have so this, it looks like this is all comments. Doesn't look like there's any code here. Well, here's some code here. And you can see if this runs. Okay. So another search that I did previously, you can search for deep learning IPYNB. And this one is a very, very nice GitHub repository. And you can download this code. I've already downloaded it. But this goes along with a book on deep learning called Deep Learning with Python, 2nd edition. I highly recommend this book. You can click on the link here, and you can read it for free. Just click here, and you can start reading. This book goes along with with the notebooks. You can follow. So I think this book is an excellent introduction to deep learning. I highly recommend it. Was there anything else I wanted to show? Oh, okay. One other resource I would like to show that I've been working on is it's called Hacks for Dev. I guess I already have it, .org. And something wrong. It must be Hack for Dev without the S. All right, there we go. And this has some very extensive tutorials that you can do. For instance, this one on galaxy classification. So I can take this, I can get the code the same way. I download the zip file. I show in folder. I unzip. And there it is. And then I can open this in my Google Colab. So let me go back to my Google Colab. I can start another Google Colab window if I want. And I wish I knew how to get rid of this bar. It's very annoying. I put it down there. All right, so let me upload a file. I'll choose a file. I'll go to my downloads where I just was. Take this. Let's look at the first one here. Okay, and we can try to run this. It may or may not work. You may have to do some debugging. That's the basic process. And you can go through here. This tutorial has some exercises. It's running. Okay, so so it gives you some exercises. It goes through this image classification example. So that's what you do. If you want to do something in machine learning, find a Jupyter notebook that does something similar. And okay, so here I have to install this. So there are some further. So let me see if I can make this work. If I need to install this, let's see if I can do this. Let's see if that works. All right, let's see. All right, so I would have to research how to do this in more detail. Oh, I see. I have to get it from here. I would have to get it from here. So that's a little bit more involved. I only have 5 minutes. Right. So just to recap from this document, there are several stages. Obtain a platform, acquire basic understanding. You can do that in W3 schools. Learn about Python packages. You can also do that in W3 schools. There's additional machine learning tutorials in W3 schools, and you can search for machine learning notebooks online. And you can do all this using Google Colab. You don't even need to install anything. All right? So I didn't leave that much time for questions, but I think I'll stop here, and I will stop my own personal recording. So I think that